Is vertical and horizontal what's called the line thing?
Asymptote?
Yeah. Is that like do we have to find that for the domain? No, that's not
No.
part of the domain. Right?
No. So x plus 1 is 0 when x equal to 1. So it's positive here, negative here. 3x minus 1 is 0 when x is 1 over 3. So it's negative here, positive here. So when you multiply the signs or dividing the signs, I get 0 here does not exist, minus, plus, plus. So that means the answer is either here or here. You see here, so the only tricky things is that you cannot include 1 over 3. So I just exclude it, you see? I said x greater than 1 over 3. Because 1 over 3 is not in the domain. So now I want to ask you how you, is that clear, this first question? How about the second one? How you could do the second one? Factoring, exactly. How can you factor this? Synthetic division or long division. So you basically, we know that one of the factors here is x minus 1. One of the factors is x minus 1. So you divide this by x minus 1. So we want to factorize x cubed minus 3x squared plus 4x minus 2. So this is equal, I know one of the factors is x minus 1 times something. So I want to find that the other factor. So I have to divide. So x squared minus x cubed minus 3x squared plus 4x minus 2. Divide by x minus 1. So it's x squared division. It's just division of the polynomials. It's exactly like the long division for numbers. That's it. That's what I'm doing. Minus 3x squared plus x squared is minus 2x squared plus 4x minus 2. Now you have to divide by x. Then you get minus 2x. So you have minus 2x squared plus minus 2x times minus 1 is plus 2x. That's it. Now then you subtract again. So 4x minus 2x is 2x minus 2. So it's just plus 2. So you see the remainder is 0. Here's the point. Because one of the factors is x minus 1 for sure.
Is the x minus 1 is a factor for every single equation?
No.
No?
No.
How do you know x minus
That's
1?
accidental. Oh, that's a good question. How did I know that? Can anyone answer why x minus 1 is a factor? Why x minus 1 is a factor?
Because the number of the constant at the very end, one of the factors is -1.
No. The reason is the sum of these coefficients are 0. So what are the coefficients in this equation? This 1 minus 3 plus 4 minus 2. These are the coefficients of my polynomial, right? 1
minus 30.
So these are the so x cubed is 1 times x cubed, right?
Oh.
1 minus 3, 4 minus 2. So you see the sum of these coefficients is 0. So that means x equal to 1 is a root.
you also determine the root from the constant? Then-
No, just the constant? No, okay.
No, because you can tell like the sum of the roots is plus or minus 1 or 2.
Yeah. You can say sum of the roots, yes, is minus 2.
Yeah,
The product actually is minus 2. But this is easier.
not for me.
No, I mean that doesn't work always. But here, if one is a root, that means the sum of the coefficients are 0. So basically, whenever you have a complicated polynomial, you have to try like simple numbers, like x equal to 1, x equal to 2. Just some try to see. But x equal to 1 is a very easy try, right? Let me give you another example. For example, if you have x cubed minus x squared plus x minus 1. So do you agree that x equal to 1 is one of the solutions, right? X equal to 1 is one of the solutions. Do you agree here?
Yeah.
That's it. So it's obvious. I mean, you don't need to think hard, basically, what
So
I'm
you
saying.
look at the coefficients and you find the sum of that coefficient, and then
Yes, or you don't need to put this in complicated words. You just look at this equation. You see when x equal to 1, this is 0. That's it. I mean, forget about the coefficients and these things.
X equal to 1 is 0.
Is a solution, yes.
yeah, I mean for the previous question.
The previous question, yes. X equal to 1, you see 1 minus 3 plus 4 minus 2. When x equal to 1, you have 1 minus 3 plus 4 minus 2. It's 0. It's a simple thing. What my point is that it's not a complicated theory.
If that equals 0.
Yeah.
Here we repeat it.
So if at the original equation, x cubed minus 3x squared plus 4x minus 2, right? When x equal to 1, you have 1 minus 3 plus 4 minus 2, which is 0. So my point is this is simple. It's not a deep thing.
Yeah, but okay, so if you have the something equal to 0, that means you have x minus 1.
Exactly. If I have a root, exactly. If I have one root, like 1, 2, that means there is a corresponding factor, like x minus 1, x minus 2, whatever. Okay?
So if
So-
that equals to 0, that's x minus 1, right?
Yes.
If that equals to 1, then this is x minus 2.
No, you can't say anything.
You can't say?
If
That
some
only works
x,
for x.
if some x makes the whole thing equal to 0, basically if you have a 0 or root of the equation, then that is the corresponding factor.
Okay, what if on the test, the coefficient doesn't equal to 0?
Yeah, so I don't give you something very
Okay.
complicated. Okay.
Did you post the recording for this afternoon's lesson on? the-
Yeah, sure.
I'm
Okay.
not writing this down, I'm trying to understand. so
Okay.
I'm-
That's fine. So, okay, so one of the factors, as we discussed in details, is x minus 1. So what is the other one? Is x squared minus 2x plus 4 plus 2. So that means the other factor, let me write it here, is x squared minus 2x plus 2. But this one doesn't have any other solution. You cannot factorize it further. Do you know why? X squared minus 2x plus 2.
Can it be x minus 1, x minus 1?
No. Because there are two ways actually to see this. One is this b squared minus 4ac is negative here. So there is no solution, no real solutions. Or you can say x squared minus 2x plus 2 is just x minus 1 squared plus 1. So it's x minus 1 squared plus 1. So you see, it's always greater than 1 or equal to 1. So it doesn't have any other roots.
Why can't you factor it? So 1 times 1, oh, 2. Okay, wait.
So this x squared minus 2x plus 2
How did you get to x minus 1?
doesn't have any solution because b squared minus 4ac is 4 minus 8 is minus 4 is negative.
Oh, doesn't have any root.
So that means this expression doesn't have any root. Or as I said, another way is that this guy is equivalent to x minus 1 squared plus 1. So it's obvious from here because you have something squared plus 1, this cannot be 0. This is always positive. Okay, now that's it. So there is only one root that is x equal to 1. So you have one linear factor, one quadratic factor. Yes.
How did you get from this to this? Can you show me the process?
X squared minus 2x plus 2.
Yeah, so x minus 1.
So what is x minus 1 squared? Tell me.
Yeah, I know, I can do it from here to this, but not this to this.
It's the same thing. If you do it a lot, you can go back and forth.
But this just completing the square.
Yes.
Oh, that's completely square.
Completing the square. I can tell you later because this is not part of our course, but I can tell you, explain this to you.
Is this in our test?
This is grade 10 or 9, completing the square.
Remember. I'll move on.
Okay. Don't worry, I can explain it to you. But so the bottom line is there is no roots for this expression, right? So the bottom line is x cubed minus 3x squared plus 4x minus 2 equals x minus 1 times x squared minus 2x plus 2. And the second factor, which is a quadratic, this guy has no roots. And this is important because whenever a quadratic equation, remember, whenever a quadratic has no roots, it's either always positive or negative. Whenever there is no roots for a quadratic, it's either always above the x-axis or below the x-axis. Here it's above because the coefficient of x squared is positive. So this is always positive. Because you have 1 times x squared. If it was negative x squared, it would be always negative. Yeah.
The sound for the recording on, like, can you, like?
Yeah. Okay, so and now here is the point. The sign of the whole thing only depends on the sign of x minus 1 because there is only one factor that here is important. So I write each of them x minus 1 and then x squared minus 2x plus 2 separately. But as I said, the second factor, the quadratic factor, is always positive. So this is always positive. However, this first factor is 0 when x is 1. It's positive when x is greater than 1, negative when x is less than 1. So it means altogether, the sign of the whole thing is positive here, negative here. and it's 0 at this. So because we are looking for positive solutions, so that means the domain is x greater than or equal to 1. Okay. So, any questions so far? Okay. Now, another type of questions that one can ask is the horizontal vertical asymptotes for rational functions, which I don't repeat. So find maybe just one quick. Mhm. So here you see what is the horizontal asymptote? Because the degree of the denominator is bigger than the degree of the numerator, the horizontal asymptote is y equal to 0, or in other words, the limit of f of x. You see the limit of f of x as x goes to infinity is just 0. The reason is because the degree of the denominator is bigger than the degree of the numerator. So y equal to 0 is a horizontal asymptote. How about vertical? Vertical asymptotes basically are the roots of the denominator. So for vertical asymptotes, you have to solve this. This is x minus 4 times, oh sorry, x minus 3 times x minus 1. So the vertical asymptotes is x equal to 3 and x equal to 1, right? If you have something like f of x equal to 5x squared plus 2x minus 1 over 1 minus x squared, then here the degree of the denominator is equal to the degree of numerator. So the horizontal asymptote here is minus 5, y equal to minus 5.
And do we have to graph?
No. Okay, so Another type of questions that one can ask is this is about there is a name of the theorem. Let me see what is the name of this theorem. For factoring polynomials. Oh, it's called the remainder theorem. Remainder theorem. Good to know. So remainder theorem is basically this. If you have f of x equal to x minus a times p of x plus some constant c, then obviously f of a is equal to c. I mean, this is something obvious. If you have one of the fact, if you basically divide f of x by x minus a, the divisor is x minus a, you divide, you get p of x, but the remainder is c, some constant c. That means f at a is equal to c, right? Because it follows from this, because you see, if you plug x equal to a, because x minus a would be 0 when x equal to a, so f of a is just equal to c. Now that means if you have a function who has a factor, in particular,
So this only occurs when x and a are the same.
yeah. In particular, if c is equals to 0, then f of a equal to 0. Like what we discussed earlier today. If x equal to 1 is a 0, then x minus 1 is a factor. Okay? Okay? Is that clear?
Can you maybe note that the x and a has to be the same on each sheet?
What do you mean the same?
Because it's f of x at first, if it's f of a, then a is plugged in.
No, you plug in x.
I plug x equal to a. Yes.
Oh, what?
No, let me give you an example. No, don't. Let me give you some simple example. For instance, if f of x is like x minus 1 times x plus 1, is it clear that f of 1 is 0?
Okay, I got it. Because if x is equal to a, so the a minus a is 0.
Exactly.
So we got c.
So that means this one would have no.
There's
So
there's
a
no
and x
remainder,
is the
yes.
same. Because you plug a into the x, so a is x.
No, in general, here when you use x is a variable.
Yeah, but like
X can be
I'm saying,
anything.
If you're plugging a into the x, then
Yes.
a and x is the same. That's what I'm saying. You
Okay.
guys are telling me no, it's not the same.
Okay. This is basically the remainder theorem. So now I can make some questions based on this. For example, if I tell you that if f of x equal to 8x cubed plus 10x squared minus px minus 5 has a factor of 2x plus 1 with no remainder. When I say a factor, means there is no remainder. Find the value of p. So I know that this guy has a factor of 2x plus 1. But remember, the trick is, the point is to use this theorem. So here, it means that f of x basically, so 8x squared, x cubed plus 10x squared minus px minus 5. I know that this is equal to 2x plus 1 times some px that I don't know. I can find it eventually, but I don't need to, basically. That's the point. So I want to find, let me use another letter because I have used p here. Let's see, g of x, q of x. Okay, now, so what you can do here at this point? No. So these things, so it's very simple. Don't make it complicated. Here, life is very simple. No, look, when x is equal to minus 1/2, the right-hand side is 0, right? So just plug in. That's the point. So the right-hand side would be 0, right? So now what is the compute the left-hand side? Let's evaluate the left-hand side when x is minus 1/2. So minus 1/2 cube is minus 1/8 times 8 is minus 1 plus 10 times minus 1/2 square, so it's 10/4 minus px, which is plus p half minus 5. That's it. Now you can find p.
So basically what you do is you try to make the right hand side to 0.
Exactly.
Find that number, and then you plug it into
Equation.
the left hand.
Yes.
So the value of p. Okay.
So now you can see what is the value of p. So so p half is basically equal to 1 minus 10/4 plus 5.
How come x cubed is gone from the equation?
It's not gone. Minus 1/2 cube is minus 1/8.
Okay.
Minus 1/2 cube is minus 1/8 times 8 is minus 1.
Wait, so the negative one half is blocking the left side.
Exactly. So I just wrote plug in x equal to negative 1.
You plug in right 8x cubed dot negative 1.
Yes. What is 1/2 cube? One over 8. Right? Okay, so here you can find p. I don't write the computation, but that's it, right? Is that clear? Do you want me to give you another example? And once you find P here, you can find also Q of X, which is the quotient, which is called the quotient. Okay, let me give you another example. Maybe more complex. So let's say that, suppose that f of x equal to, no, but it's easy. First you have to find P here, for example. And then you plug in, then you just divide, use the synthetic division,
Okay,
which is basically the long division. So
so what's the factor for, so x? 2x plus 1, that's the factor for that's the thing you divide for the
exactly,
mathematic.
yeah.
Okay, got it.
So suppose that f of x equal to x cubed plus ax plus b plus ax squared plus bx plus let's say 8 has a factor of x minus 2 and x minus 1. Then compute A and B. So because we know that we know two factors here. So basically we have two equations and we also have two unknown, A, B. So here, x cubed plus ax squared plus bx plus 8 is equal to x minus 1 times x minus 2 times something that we don't know, let's say qx. That's it. The remainder is 0. So that means if let x equal to 1, so on the left-hand side, what you get? On the left-hand side, you get when x is 1, you have 1 plus a plus b plus 8 equal to 0. Now let x equal to 2. So that means on the left-hand side, you have 8 plus 4a plus 2b plus 8 equal to 0. Two equations with two variables. Grade 9 math. Find a and b. Okay. Now, do you know how to solve these two equations?
Yeah.
Can you tell me what is a and b?
I'm not yet.
Is it you subtract or something?
Yeah, you can do
Or
that.
you substitute?
Substitute, yes, substitute.
I don't know exactly. Just use subtract. Okay.
The bottoms?
Yeah, just use subtract.
Okay,
Wait.
so you have two equations. One is basically, these are the two equations. A plus B is -9. That's the first equation. The second equation is 4A plus 2B equal to -16.
How did you get that?
Because you have 8 plus 8 on the left-hand side, which is 16. You take it to the right, comes -16.
So for these equations, you want to like isolate for A and B, right?
Don't have to, but I just,
You don't have to take the 9 to the outside out. You have to, or do you?
no, you don't have to.
Okay. You can just leave it A plus B plus 9.
Yes,
That
you
kind
can
of thing.
just, yes.
I got it.
Okay, so if you use substitution from the first equation, B is -9 minus A, or let's say A is, from the first equation, A is -9 minus B. You plug this into the second equation, you have 4A. So you have 4 times -9, which is -36, minus 4B plus 2B equal to -16. So -4B plus 2B is -2B. -16 plus 36 is 20. B equal to -10. And A would be -9 plus 10, which is 1.
Where'd you get? -36.
4 times 9 is 36. 4 times. This is just substitution. Okay, so B is -10, A is 1. That's it.
So, so if you want to factor these equations, you gotta factor x minus 1 and x minus 2, and the remaining part can use the cube of x. or the-
Exactly. But here, actually, let me ask you this question. First, is this clear so far? This question. Can you tell me what is Q of X? Because Q of X now it's easy to find. There is only one, because here you have a cubic equation, right? So it has 3 first order equations, like x minus 1, x minus 2. The last one is x plus or minus something. So what is that constant number? You see the product of these numbers, -1, -2, and another number must be 8. Because when you multiply x minus 1 times x minus 2 times x minus, say, I don't know, 3, the product of these numbers must be 8, right? The constant number on the left is 8, right? Think about this. Find the QX. Let me tell you this. But QX is x plus 4.
Is it because the constant of the left hand, the last number is 8, so the
Product.
the sum, the product of the right hand is 8. That's why, right?
The numbers, constant numbers, yes.
So if that number was something like bx plus 9, so that means the right hand has to go to 9, right?
Would be 9, the product, yes.
Okay, that makes more sense. Because you said h popped up from nowhere.
Okay,
So it all depends on the last number.
what do you mean?
So, like this number, right?
Yeah, yeah,
Is
yeah,
that right?
yeah, exactly.
Okay,
Exactly.
good.
So the finally polynomial is depends on the last number.
No, I mean, of course, the polynomial depends on each of the coefficients. But what I'm saying is that the product of these constant numbers that appear here, like -1, -2, and the other one must be equal to 8. Yes, I will tell you, don't worry. Again, this is, you know what? Because you overthink, all of you. You overthink. You think
Maybe
more than
maybe just me and Alex.
maybe you overthink. It's easy.
I'm an overthinker.
The overthinker, yes. If you think simply, you will be good in math, honestly. Simple. Simple solutions. Okay, I will tell you, it's not deep. It's not deep.
So can you do the process finding the QX?
Yes. Okay, let's call it for today.
So only these 3 times are going to be on the test
Around this, yeah.
around this. But this is kind of new, like
Okay.
kind of new.
Okay.
X minus
I will
1.
write it on the whiteboard for you. Miss Ron, do you have any question?
No.
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 No.